Finally, we have another digital to analog signal conversion technique that is known as phase shift keying. Okay, so here we are basically work on the phase of an analog signal to identify different bits. Okay, so what is the phase of an analog signal? We have already known it. So this figure will help you to understand the phase. As you can see, the signal starts from the phase of 0 degree, and at this point the phase is 90 degree, and at this point the phase is 180, at this point the phase is 270, and at this point the phase is 360, or as you can see it is again going to its base position or starting position, that is 0 degree. Okay, so an analog signal basically repeats this pattern time and time again. So in from the starting point of an analog signal, we basically can identify the phase of an signal. Okay, so let's see, or let's say if the signal starts from this point, as you can see, this represents 90 degrees. So if this one is not present, so this signal will have a phase of 90 degree. Okay, and similar to that, if the signal starts from this point, then this signal, that is the right side of the figure, will have a phase of 180 degree. Okay, so from the starting point of an analog signal we can identify the phase of a signal. So in phase shift keying, we basically change this starting point of an analog signal or change the phase of an analog signal to identify different bits, right? Okay. So here is an example of binary phase shift keying. As you can see, if the bit is 1, we are we have the signal with the phase of as it is starting from this point, it has a phase of 0 degree. Okay, and if the bit is 0, then we are starting from this point and it is going downwards, so it has a phase of 180 degree. Okay, so basically for 1, here we are using 0 degree phase, and for 0 we are using 180 degree phase. Okay, so based on this phase for each signal elements, the receiver can identify either we are changing, we have sent 0 bit or 1 bit. Okay, and one important thing is here that as you can see, look here, the frequency and amplitude of the signal remain unchanged. We only changing the phase of the signal, right? That is why it is known as phase shift keying. Clear? Okay, here is another example of binary phase shift keying, as it is our carrier frequency, and based on ones or zeros we have changed the phase of this signal.